Hello friends, welcome back for a new video. So today we are going to see one more new manuscript from one more reputed channel of Springer. So just go to the website for getting the details of the manuscript which we are going through. So today we are just going through a journal, International Journal of Computer Vision. So, what is the reason for choosing that journal? So, of course, that is one of the highest impact factor journal in Springer Man series here. Just go through the credentials of this journal. So, this is International Journal of Computer Vision. This is the home page of this journal, and you can see here the credentials. The impact factor of this journal is 5.698, which is one of the best impact factor. And 5 years impact factor is 11.042 in 2019, and you can see there are very good number of downloads, nearly 5,18,673 downloads are there. So we have chosen this journal for taking the manuscript for revising here, right? And in this we are going for the current issue. So volume 129, issue number 7 July 2021. From this issue, we are taking one of the interesting paper, mitigating demographic bias in facial datasets with style-based multi-attribute transfer. So just you can click to this link here and you will get this paper open here. And of course, this paper is also an open access paper. So it's better for going for an open access paper because it will be easily accessible for everyone, and they can able to go through the paper and they can go through the real content of the paper. Okay, so a small request for all the users here, whoever are here, so just go through this video and go through my channel here and try to subscribe the channel, because here every weekly basis on every Saturday evening 5 o'clock we are going to upload a new manuscript, and we are completely going through the details of that manuscript, like minute details such as what are the real novel contribution of that manuscript here, that all things we are, and we are trying to make as precise as possible by making the video in a small content here, right? And one thing here, just you can click on to this download button and this manuscript will be downloaded for you, right? So and already we have downloaded the manuscript here, so just we can go through that version here. So this is the manuscript here. So let us start the video with this manuscript here. So the title of the manuscript is Mitigating Demographic Bias in Facial Datasets with Style-Based Multi-Attribute Transfer. So, what is the main intention of this paper? What is the main goal of this paper? So, here you can just go through the abstract and you can have more better view about this here. So, if you go through the abstract here, so abstract is telling here, so the deep learning has catalyzed progress in the tasks such as facial recognition and analysis, leading to a quick integration of the technological solution in multiple layers of our society. So here in this paper, they are going to use the deep learning technique for improving the facial data set recognition. So the shortcoming what they are finding is that they are giving that a little less amount of biased data sets are available everywhere. You are going to have the data sets which are having like fairer faces, which are in white in color or which are from only one particular region. Depending upon that, here if you are going to use one particular face recognition where we are not having a particular type of samples which are not trained, then the facial detection data set algorithm is going to fail, they are telling here. So there is a problem called as exhibiting that accuracy does not entitle fairness here. So fairness accuracy is not there. Means accuracy is there for some category of pictures or faces. The accuracy is good here, but not for all. They had just taken an example that if you are going to take a male or a female, like from a black toned skin tone is black, in that case there is a problem of accurate recognition. The reason they are stating is that as the training process is not done on such type of instances, so due to that there is a downfall in the accuracy. So, in this work, what we address the problem of mitigating bias in the facial data sets. So, that bias, what is there, that they had mitigated by using the technique of data augmentation. So, they are using deep learning technique to make the data augmentation and change the facial expressions of that particular person, like in the skin tone or in the age point of view, and then they are training their model to work better on such type of data sets also. That is what they are telling here. And indeed they have proposed this algorithm, this framework, by using a good diverse amount of data sets here. They had used a good amount of data sets from different sources, and they have used different algorithms for comparison. And the paper in overall is a very good paper. There is no need for advocating that this paper is a good paper, because it has published in a very good journal here, International Journal of Computer Vision here, which is one of the topmost journal in the computer science here. So then going for the paper here, so the introduction, they are just telling what is meant by deep learning and how that models are used here. And then going for the main thing here, they are telling here, this is despite the fact that the algorithm may appear accurate given current evaluation metrics, but inherently fail to capture the properties such as fairness and diversity. So when you are going to give the samples of the diverse cases, you are taking the images of the little untrained model, then the model is going to fail. At the same time, there is no fairness also for all the category of instances. So in that scenario, they are just going forward, and yeah, they had given the main contributions of this paper as follows. So they are telling that here we introduce a novel style transfer GAN. So GAN means here generative adversarial networks. So that is what they said, the deep neural networks technique which they are using for augmentation work here. Able to transfer multiple demographic attributes simultaneously, so by conditioning a different set of target images. So they are taking different type of target images and trying to convert them by using this GAN deep learning technique, augmentation technique, and then trying to use on their framework here. So let us, and showing that it was very much efficient. So that is first contribution what they are specifying from their side. And then the second one is a multi-attribute extension for ADIN is presented. So you need to know what is this ADIN. It is nothing but adaptive instance normalization technique is there, which is used for normalizing the different attributes for getting the better details regarding that for further processing. So that is also they are using, and they are making the extension of that one. And of course, in the third thing, they said that they had did a series of qualitative and quantitative experiments. Yeah, that's what they had used, a number of data sets which are of a high instance in number. At the same time, they have used here different algorithms which are of different variety, like the algorithms which can work on multi-class attributes, and the algorithms which can work on multi-features attributes. They have taken a good number of qualitative experimental analysis. And then they have given that we provided a thorough investigation of how datasets bias affect classification performance and show how more diverse data sets can be used to train. Yeah, they had used that one also. And on two data sets, they have taken some more thing here, MORPH and KAN phase. So these are some of the data sets which they have used for their experimental analysis. And then the section 2.1, they are giving about what is this generalized adversarial networks and style transfer. That means how the data is transferred from the image to make the augmentation process, so that they are presenting here. And then they are giving some more details about IDAIN also, that is nothing but adaptive instance normalization technique. Details of that one are also given, right? And then just going for this picture, this picture is the real picture which gives the total idea regarding what's going on in this paper here. Just you can go and concentrate here. Yeah, so now here you can see, so this is what called as multiplicative fusion technique, which they are using, where they are using multiple features and going for fusion of those multiplicative features, right? And here this is a picture, this is a facial picture which is going to be recognized. And they are using xg1a1, they are extracting by using ADAIN, that is nothing but adaptive instance normalization. By using that technique, they are going to find out the main features of this face, like G1 A1. G1 is gender, A1 is age. And then they are going to generate from that G1 A1, they are going to generate mu del, these two values they are generating. And then they need to have a target, so this is the target attribute, right? So this is another one, this is another phase with xga, so that is nothing but xg0, that is nothing but another gender characteristics they are trying to get from here. And then they are get the age characteristics from this picture. This picture is a aged person picture, they are getting the age characteristics from this. And this is a different gender picture, gender picture, where we are they are getting the different gender details, and these different gender details and these different age details are taken from here. And the input image is taken here with this particular gender of female and age of something like 20. And they are mixing this one, they are mixing this age of 20 with age of something like 60 plus, and getting the new image. At the same time, they are taking the gender of female and taking the qualities of male gender picture, and trying to convert this female image into a male image. That is first thing. And second thing, they are trying to convert this 20 years age, 20 or 20 plus years of age, to a 60 plus years of age by using this target picture extraction. And overall, this is the new face what they have prepared by using their augmentation technique, like generative adversarial networks, and by using adaptive instance normalization. This is the new picture what they are getting, which is of different age and which is of different gender. Now, what they are telling is that the problem of this main research, what they are specifying is that if you are going to give a new picture which is of different category, like a black toned female image you are going to give, then the existing systems may fail for identifying that one as a female, or male as a male. So for solving that problem, what they are trying to have is they are trying to just get diverse type of images for training by using the augmentation process. That was the main scenario of this paper here. Now they had given a very good reference for showing the problem. Just they had given a link here, but we have used it better way here. Let us just see here. If you go back to that particular place and we'll come here. Okay, just a minute here. So we are going to a link which was given in this paper regarding that category. So here you can see, yeah. So they had given two type of commercial existing face recognition business companies like Face Plus Plus and Clarifia. So you are going to just go there. So this is Face Plus Plus. Okay, where we got this website here, and then just go for this Clarify also, right? So both of them are available. Now what are these websites here? Let us just go through this Face Plus Plus. So this website is a face and recognition system here. So here you can see that. So there here is a picture. From this picture it's able to identify what is the picture. In this picture one face has been detected and it got some unique face token. So if you click on this, you are going to know what is this face about. So just you can see this age of this picture in the face is 24 and the gender is female, and the value of smiling is also given as 0.104, and threshold 50 and all those values are there. And head pose is just bent out like this here. Left eye status is open, right eye status is open, and no glasses. So this much exactly they are going to give the details. If you go through another picture also like this, if you are taking a new picture, so in this new picture also they have detected two faces. Now this is one face which is of age 60 and male. This is another face which is of 60 and female, right? So this is one of the commercially used system here for face recognition. They are ready for the business. If you want here, they can come and have this one Face Plus Plus. Then after that you can see one more website what they had given here. So that is Clarifia. So here also is the just to see how the computer vision has just improved. So now you can see there are apparel detections. That means what type of apparels you are using, that clothing, etc. So that they can take a picture, and from the picture they can see all that. So that much detection is there. If you see this picture, in this picture it has given a clear thing that what are different type of apparels here. There is shoes, dress, shoes, and bracelets, and you can see just pointing on one can give you idea also. So the shoes are 1.00 probability. That means that's 100% it's shoes. They are guaranteed and completely it's shown. And bracelet 0.9393, because it's, see, this is the bracelet what they are pointing out, but only 0.93 out of 1 is shown here. So that is the way how they are identifying. So now you see about another picture. So this picture, if you see here, yeah. So by processing this picture, what they got the result is that there is a top. So where is the top? Yeah. So if you point out, you will get the top. There is a pants, and of course there are shoes for this picture. So if you can see, yeah, there are shoes, one shoe, another shoe, and then ring is there. You can see the ring here. The ring is also identified, and necklace is there. So necklace like that, everything can be identified. What is the practical problem the others are telling is that now you can see here for both websites they had given an option of uploading your picture. You can try your own picture. So now here there are so many options you can see here. This is where we are going to find the details of their clothing. Now if you go back to the same website and you just go to this general category and you open this, then you can see if you are uploading any general picture, from that they are extracting everything. This is one picture. From the picture they are extracting the dawn, water is there, 0.995 water in the picture here, good percent dusk. So boat is there, reflections are they are capturing, that's reflection is here, sun is there, beach is there, composture, so everything is there. So you can see that how much the different type of facial recognition systems are working nowadays. But in spite of that, they had given a drawback here that that picture can't be able to identify it properly if it is having a black tone. The reason black tone they are telling is that because it will be very lessly trained. So most of the data sets what you are getting in the machine learning or in this facial recognition are of a light tone, that is white tone, and due to that reason the system may not be aware of finding a black tone differentiation in a proper way. So let us see a practical example of their limitation what they are telling. So just you go to this particular website, that is our face press press, and for sample purpose you can upload a picture here. So we will try to upload a picture which we have just downloaded from a particular website. So this is, of course, this picture is of a female. What we can see just now, this is a female picture, of course. Yeah, this is a female picture. Yes, and we try to upload this picture and ask the system to recognize. Is it able to recognize this female picture as a female or not? Let us just try. As it is going to the target of a black tone and it's a female, it need to be identified. Let us just try with this one here. So their face press press. Now let us just upload here. Upload, and here you can see a captcha for their protection. That's very much needed. We are trying to give the right captcha. If so, let us see. Yeah, FZ is also there. Yeah, it allowed us. It's taken as a human. So from the desktop, we are trying to upload this picture. Of course, this download. We are uploading here, and now see the stunning result. So, of course, just now we had given a picture within split of seconds. This face recognition software has recognized that some details about the picture. One face has been detected, and it got unique features. Click on the face image to get more details. And here you can see a blender. So, gender they had recognized it as male, and age is 24. Of course, age is 24. Smiling value also they are giving 0.17%. Now the thing is that they are giving gender as female. So that was the main reason. So what the others are telling us, you got the point now. So that is the practical demonstration of this particular point. What we are telling that if there are black tone images of male and female, then the system is of course going to not recognize. So on that problem only the others are working, and they have developed a good system. So now what they are telling, we will try to take the white tone picture and we will try to convert into a black tone picture, and then we will try to train our network on those black tones also. Then in that category there will be no chance of misdetection. This is a commercial product, face plus plus, and it's going there here on the open market, and still we are finding this limitation here. And it's not that this face plus space is just not like that, it's working. Let us just see some more pictures. It works. So like now if you see one more picture I try to upload, so here also you can see the existing pictures are there, the sample. Now in this picture it's recognizing three faces. Right now, what is this face? It's a male person. What is this face? It's a female person. What is this face? It's a female. It's working. It's working. Now if you see about one more picture from our downloads only, we have just taken some more picture of download. So you can see this is one more picture which is a black tone. This is a black tone picture, but still it has identified how it has identified as female. There is no problem. And again, we are trying to take one more picture of a popular celebrity, and of course it's working. So now you can see this picture is of one more singer here, Rihanna, and you can see the result of this picture also. Of course it's processing. Now the face is detected and it's female, 21 years. It's okay, the system is well working. But the issue is that when you are going a very discriminative or very different category of picture like this here, where it is very black tone in color, and of course it is a female picture, you know that thing. But the system is going to consider it as a male. So the reason is that it is not trained in that particular area. That is what the main point of this particular paper. So what they are telling is that one. So let us come back to this paper. So here, so what they want to now do is they want to take the picture, target picture, and convert a white tone into a black tone and skin tone, and try to run their system, try to make the training so that it can work out better. So that's what their intention of that paper here. It's a good point what they are finding out. After that, they just go through some fairness aware learning and basic analysis descriptions, then methodology what they are using in this one here. So drawing from the inspiration of style transfer GAN literature, they have used that style transfer GAN, that is generalized adversarial networks, for their work also. And they have used the ADAIN, adaptive instance normalization also, and they had extended that one and they had proposed. So of course it's a good proposal. They did a lot of mathematical evaluations and they had shown it here, and they had implemented those things here. Now see the experimental analysis. I mean, the experimental analysis also, they have did the experimental analysis of the data sets which are of wide variety. We demonstrated the ability of method to synthesize realistic face images covering all demographic groups. So demographic means different areas groups here. They are taking that and finding out, and they are taking different ages also, different age groups also. Now, if you can go and see the details of their data sets, so these are the details of their data sets. So they are taking the data sets MORPH and CACD and KAN phase and UTK phase MORPH. So they are having good number of instances, like 55,000 instances in one case, 53,000 in another case, and 1,60,000 images in another data set here. So the data sets are of very diverse categories. Say they had taken 20,000 images from this one, okay, and they did different type of results analysis. So attribute transfer, when they do attribute transfer, how the things are going on, and all those they have seen it here. Just go through here. So here now you can see the analysis what they did here. So now, yeah, you just go through this picture so for better understand. So now you can see here. So their algorithm is what they had written as ours, and the above algorithms ATTGAN is one of the proposal which they are using for comparative purpose algorithm. This is an existing algorithm, IPCGAN, CAAE. So one, two, three, four algorithms they are using, and they are trying to take this sample picture and trying to convert it by using that augmentation, okay, by using deep neural networks. And they are converting in the ranges. They are taking 0 to 18 age, 19 to 30, 31 to 45, 46 to 60, 61 plus. So this red box is the actual image. They got the image of this 31 to 45 age, and they are trying to reduce it to the 18 years age. They are trying to change it to the 61 plus years of age, and of course they are converting this one into a female, and they got a male picture, they are converting it to female. And in other scenario they are got female picture, they are converting into male. And of course here also you can see the superiority of their augmentation technique. What they are having, it's better than the other proposals you can see. In the same way, for this picture also you can see this is the real image what they got, and this is the conversions how they are doing. And this male image is converted into female image. And here this is Angelica Jolie, I think so here. So now her image is also just converted, of course. So now it's to female image, it's converted into male image, okay. So the bottom row is their row, their proposed algorithms here, and they are showing that they have did better on that particular data sets here. And like that the things goes on, and it's a good paper which has given a good details regarding this one, okay. And now if you want to have some more details regarding this here, these are the proposed algorithms. So you can have the code regarding this here. Just click it here, CAAE. You can have the code regarding that here. Open source code is there for the for the compared algorithms here, not for the proposed here. And of course, when you go for this one, GAN, that is nothing but generative adversarial networks. For that also the code is available here. You can take the code from this, and for do make the things here. And another one here is here, star GAN is also one there, where it you can just click here and go to the GitHub. जी okay जी इसके बाद then we can see one more here about this one, ATTGAN. This is also one more contribution. You can go through all these here for your better understanding. And then going a little more for this one here, so you can see then they had given some more details. Some more details are there, right? About this one are the two these are the two commercial systems which we have just gone through for identifying that different change here, facial face plus place and clarifia. So these two are there given as the hyperlinks here, and this is how they are predicting the age. So age is now actually see this one little more elaboration with this facial recognition example. You can understand more. So now with this you may understand little more. Yeah, you can see. So this is an input image, and this is the target image. So input image is a male image, and the target image is female image. We need to convert this male into a female face first thing, and with that we need to have the features of this image and this image, both has to be combined. So if you take this image and convert into transfer into a female image, it will be like this. Okay, then you are taking this female image and you are taking this image, target image. From this target image you are taking the female characteristics, and from this image you are taking the main characteristics and combining these two and finding this is just not the transformation of this image. So here we are transforming this female image and male image and combining these two and getting the main characteristics. So here also you may just confuse here. This is the input image, this is the target image. So age change. So you need to change the age characteristics and combine. This is the resultant image, what you are seeing. So this is the result. And here also this is the result image of their system, where they are trying to change the skin tone. They are trying to change the skin tone and gender, both will be changed here. And here you can see the age factor also, they have just changed it here. See here, this is the age here, and they are changing it to 62 age, and target image is like this here. You need to convert it. So this person face is changed to this aged here. So like that we can see different type of modifications they try to do by their proposal, and they have shown that it's going to work in a good way. Okay, and of course they are showing these are the data set details. Now yeah, they are showing here how it's working, some numerical metrics also. They are shown in the diagrammatic picture the better representation of their proposed algorithm. Now these are the algorithms which are existing: ATTGAN, star GAN, and CAE, IPCGAN, GT, etc. Now for this age SHE metric, the value 1.39 is better than the all algorithms. 0.86 it's okay, and it's better. 3.89 it's better. And all this they are telling that their proposed algorithm is giving good results. Okay, and of course they had given the limitations also. What are the main limitations? So first limitation they are pointing out is about the training on limited data. Of course they are agreeing that when they are trying to train their algorithm on the limited data, the results are not so encouraging. And they are telling that this is not with their own algorithm. This is the point with all thing, but it is for all generative model based bias mitigation methods. That was the common problem. So if we are going to investigate shortcoming, the one of the shortcoming is training on limited data. When you are trying to train on the limited data, of course the performance of their algorithm is also not good. That's the one thing. And second limitation they are telling, augmentation with real data. when they are trying to make the augmentation with the real data, the results may be a little discouraging, not that much. So that is the limitation. So two limitations they had given for their point of view. And now they are giving different approaches for generating have been proposed in the literature, and they are taking all those approaches to improve it better. Okay, then lastly they had presented the conclusion. We have came to the end of this video here. So the lastly they had given the conclusion where they are telling they are using style based neural data augmentation framework for changing the sample pictures to an extent which they want, so that they have multiple facial demographic attributes can be there, it can be transferred, and the framework can be better trained. So now just we have seen the limitation of a commercial software phase plus plus there also. They said their problem is that the limited training data. So by using this augmentation technique they can able to change it better. And now comes the lastly the future work here. So this is the future work of their extension what they are telling. So in future work we aim to extend our style transfer framework to be able to handle heavily biased data sets. So that is nothing but missing values, where we will have missing classes that can be investigated. So that they are showing here that they want to make it in their future work, and they want to have more about in the future work. So that in particular we plan to address bias beyond traditional binary things here. So they want to like gender also. So binary gender is the one of the limitation, like they are telling, of course. So male and female are the two binary genders they are considering in this study, and they want to tell that in the future if possible they want to extend their system for the transgender also. That is what their extensions. So of course the other details are also not provided here, as this is a Springer paper. In elsewhere we may have here. So of course, you can go to the top of the paper. There we are having the details regarding the other, and you can go through that here. That's what we can tell you about this paper. This is one of the good paper. I try to explain as much as I possible, but in spite of that one, I may have missed some of the minute details here. So if still anybody want any more details, you can just go through the details and have a discussion regarding that in the form of comments here. Okay. And of course, I may make one more request that go and subscribe my channel here for better videos. And of course we are going to regularly update the videos on this channel here. And don't forget to share and subscribe and like the videos. That's all what we can tell here. So today we have seen one of the best mitigating. So the point is the practical implementation also we have seen it here in the form of this facial face press press, where it's showing the male as a female as a male. And of course this also I tried it here, but uploading is not that much good here. It's not working in the uploading scenario. So there was here. So right, so that's all for today's session. So try to be continuing connected with us, and try to be continue with us here for all these. Okay, right. We are going to end up this video today here. Right. Thanks for watching this video.